a few questions about field shapes that I want you to have a go at. So, have a read of these questions, pause the video, have a good go at answering all of them, and then unpause it to see the answers. So pause now. Right, hopefully you paused and tried these out. If so, let's go. Question 1. Sketch the gravitational field around a planet. Where is the field strongest? Well, the planet is going to be roughly spherical, so we'll start with a spherical object, and then we're going to have field lines that are radial coming from the surface of the planet, and arrows are going to be pointing inwards towards the planet, because that's the direction. If we have a test object, a small test object, the direction the force would be on the test object is towards the planet. Okay, so that's what we're looking for, something like this. Now we don't really at this stage want the lines going all the way to the middle, okay, and I'll talk about why in a moment. Where is the field strongest? The answer is at the surface of the planet. So on the surface of the planet, that's where the field lines are closest to each other, and that's where the field is strongest. Now the field isn't strongest at the centre of the Earth. Okay? You might think, well, these lines might continue towards the centre of the Earth, and then the field will be the strongest at the centre of the Earth. But if you think about it, if you're at the centre of the Earth, then the field strength is actually going to be 0, because all the material around you is pulling you equally in all different directions. So there's actually no net pull in any direction at the centre of the Earth. So the gravitational field strength at the centre of the Earth is 0. So the answer I'm looking for there is the field is strongest at the surface of the planet. Right, question 2. Sketch the electric field around a positively charged metal sphere. This is the kind of thing you get on top of a Van de Graaff generator. It's not quite spherical on top of a Van de Graaff generator, it's got a hole in the bottom, but otherwise it is. So what I'm looking for here is exactly the same pattern, except to say that the arrows on the field lines are going to point away from the sphere, because when we're dealing with an electric field, our test particle is positive, and a positive test particle is going to experience a force away from the sphere, as it will be repelled. Okay, so same radial field shape, except the arrows pointing the other way. Likewise, the electric field, it wasn't asked, but the electric field is again here strongest at the surface. It's not stronger inside the sphere. Question 3. When is it fair to assume that the Earth's gravitational field is uniform? Well, here's my answer. When the distances moved are very small compared with the distance from the centre of the Earth. So if we're on the surface of the Earth, let's say, here, as long as there's stuff we're doing, if we're throwing a ball or something like that, okay, trying to work out where it's going to land or anything, as long as the distances moved horizontally and vertically are very small compared with the distance from the centre of the Earth, then we're probably all right. Okay? If we're moving too far up or down, so if the object goes a significant distance up or down from the Earth, then this non-uniformity is going to show up, because the field strength is going to be weaker here and stronger here. Likewise, if our object moves too far around this way, the field strength won't change, but the direction of the field will change. So the direction of the field here and the direction of the field here are very different. So as long as the distance is being moved are very small compared with the distance from the centre of the Earth, then we're not going to notice very much the non-uniformity of the field. So those are the three questions. I hope that's helped illustrate a few of the concepts involved.